So today we're going to go over scientific notation. So scientific notation, some of you guys have done before, especially if you can remember chemistry in middle school, you've seen it before. It's just a way to make it really easy to make really big numbers small and easier to deal with, but we're still going to use this, some of those exponent rules that we've been talking about the past few days. So you can read the definition of scientific notation, really the things to take away from it. The form is always a times 10 to the n, where a is a number that's greater than or equal to 1 and less than 10. So it can have decimals in it. It just has to be between 1 and 10. And n, so your exponent, is any integer. And any number that exists can be written in scientific notation. So we're going to go through how to change back and forth between scientific notation and standard form. So if you look at those first 6 problems you have right there, that first problem, 5,100,000, this is in standard form right now. So standard form, it's got a lot of zeros, it's got those commas in there, so we want to figure out an easier way to deal with it. So to change it to scientific notation, all you have to do is you take the first digit that's listed. So we're going to take that 5, and that's going to go in front of our decimal. So you only have one digit in front of your decimal. So that's going to be our 5, and then you put your decimal, and we're going to write any other digit we see other than 0 after it. So I see a 0.1, or I see a 1, so 5.1. And now you can see the rest of your scientific notation is times 10 to the nth power. So there's always going to be that times 10. The nth power is what's going to change each time. And the way you figure out what number n is going to be is you count how many spaces you would have to move that decimal over right here to get back to this standard form. So our decimal right now would be existing like right here. So I would have to move 1, 2, 3, 4, 5, 6 times to get it back to this number right here. So this would be 5.1 times 10 to the 6th power then. And this is the scientific notation of 5,100,000. Okay, so if you look at number 2, 2 is a little different because it has a few more digits aside from those first 2 we had over here. So this number is 80,300,000,000. Again, lots of commas, lots of zeros you would have to write, so it's so much easier to write it in scientific notation. And you guys are going to see this a lot in chemistry. This is where you use it because typically those are where your larger quantities are. So again, you're always going to write that first digit you see first. So we're going to have 8, and then we're going to write our decimal, and I'm going to write out my numbers until I see no more digits except for 0. So I do have a 0 right here, but I'm still going to write it there because I have a 3 afterwards. So it's going to be 8.03, and then you can see the rest of the numbers after that 3. These are all zeros. So that's where I'm going to stop with that first part of my scientific notation, that A. I'm going to stop there. And then it'll be times 10 to the, and again, imagine your decimals right here. So we're going to count how many times I would have to move it to the right to get back to this number. So I would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times, this would be times 10 to the 10th power. Okay. Same thing over here, looking at number 3. This one's kind of similar to number 2. Okay, now remember, A has to be, that number you choose to be in front of your decimal in scientific notation has to be between 1 and 10. So even though you see a 14 in front of the comma, we're not going to write 14 in front of the decimal, only this number 1. Then we're going to write our decimal, and then every digit you see after that until all you see is 0. So 1.425 times 10 to the, and we're going to match our decimals here, 1, 2, 3, 4, 5, 6, 7 times it had to move. So times 10 to the 7th power would be our scientific notation. So you can see you may have 3 digits here. You may have 4 or 5. It doesn't really matter. It depends on how many digits you have in your standard form before you get to the zeros. So now if you look at numbers 4, 5, and 6, changing these into scientific notation, it's going to look a little different. Same idea that we had up here, but if you notice the difference between 1, 2, and 3 and what you see down here, these are already decimals. Like, they're not whole numbers. These are really, really small quantities. These were really, really large. These are really, really small. Okay, but it's still the same process. You always want to have one digit in front of your decimal in your scientific notation. So here we would have 4.9. Okay, so if our decimal's right here, I still do times 10, but now instead of moving to the right to get it back to the standard form, I'm going to have to move my decimal to the left. So some of you guys can probably already figure it out what you're going to do. But if I count 1, 2, it takes 3 times to get it back to where it should be. So if it's moving to the left, your exponent's going to be negative. Okay, so negative 1, 2, 3. So 10 to the negative third. Number 5 right here, same kind of process. So I take that first digit I come to, and that's going to go in front of my decimal. So 3 point, and then 001. So I have to write them out until all I see are zeros. So there would be zeros after that, but this is all I'm concerned about right here. And then if my decimal were right here, I'm trying to tell whoever would be reading my scientific notation how to get back to the standard form. So times 10 to the 1, 2, 3, 4. So to the negative 4th power. And number 6, again, 5. That's the first digit I come to. So 5 point, wait, the rest that you have, 19 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. And we went to the left, so times 10 to the negative 8. So that's how you change it into scientific notation. Now if you're given scientific notation, like you are down here, and we want to change it to standard form, you're just going to be following exactly what they say. So 4.91 times 10 to the 4th. So I have 4.91. And this is a positive exponent, so that tells me I need to move it to the right 4 times. 1, 2, 3, 4. And I'm going to fill in these empty spaces with zeros. So my number, if I write it including the commas, which you don't have to, but do rewrite your number after this, okay, because this can look a little messy. It would be 49,100 would be your answer. And then with the negative exponent, again, that negative exponent tells you need to move it to the left. So we start with 3.2, but we're moving it now to the left 5 times. 1, 2, 3, 4, 5. And we're going to fill in these empty spaces again with zeros. So that means our final answer, and again, rewrite it because this is kind of messy. 0.000032. So this is our standard form of this number in scientific notation. Okay, so go ahead and I'm going to give you a minute or two. You can pause the video and work through these next 4 problems. Okay, so your final answers should look like this. Let's see, we had 1, 2, and then 2, 3, 4, 5, 6. So 603 million here. and 0.035 here, and 17,087,000. All right, so that's moving back and forth between scientific notation and standard form. You can also multiply and divide numbers in scientific notation, and this is what's going to look really similar to what you guys have been doing in class. Just think about these 10 to the powers, whether it's to the third power or fourth power. Think about those as like x to the third power and x to the fourth power, and how whenever you multiplied like bases, you add those numbers right there, so that'd be x to the 7th. Same kind of idea here when you're multiplying numbers in scientific notation. So what you're going to do is multiply first your numbers that you have. So we have 3.4 times 10 to the 3rd times 5 times 10 to the 4th. So to make this easy, I'm just going to multiply those numbers first. So 3.4 times 5 gives you 17. And times 10 to the 3rd times 10 to the 4th is 10 to the 7th. Okay, these are like bases, so I'm going to continue writing that 10, but just add those exponents right there. 3 plus 4 is 7. So 17 times 10 to the 7th. Okay, or in standard form, and if you think about it, this really isn't a great representation, because scientific notation, remember, we're not supposed to have this number right here, should be between 1 and 10, and it's 17 right now, so that's not a number between 1 and 10. So a better way to do that would be saying 1.7 times 10, and then you have to factor in, since you're adding a decimal there, if you had to move 7 spaces when the decimal was here, you're going to have to move 8 spaces if you move the decimal one more spot to the left. So this would be 1.7 times 10 to the 8th. Okay, and I'm going to let you guys put that in standard form, so that just means what you were doing up here in 7 through 12. So you would actually write out, after you move that decimal spot, 8 spaces. Okay, now number 2, same thing right here. We just have a bunch of numbers we're multiplying together, really. So I'm going to multiply these two numbers first. So 2.8 times 1.9. And I get 5.32 times 10. And then again with your exponents, I have like bases right here. These both are bases of 10. So if I'm multiplying those together, I can just add those exponents. Negative 4 plus 7 is 3. So times 10 to the 3rd power. And that would be my scientific notation answer. So you're multiplying your numbers, and then you have like bases right here. So again, this would be like if it said x to the negative 4th times x to the 7th. That would be x to the 3rd when you add those together, okay? It's just 10 is our base instead of x. And if you look 5 and 6, it's still using those properties, but instead of multiplying everything, we're raising it to the power. So 1.2 times 10 to the negative 4th. So that second power applies to this number and that one right here. So we're going to raise 1.2 to the second power and times 10. And remember, whenever you raise an exponent to a power, you're going to multiply those numbers instead of adding. So that's still using your properties. So negative 4 times 2 is negative 8 right there. And you still have to finish this though, since you know what 1.2 squared is. If you put that into your calculator, you can see it's going to be 1.44. So this whole answer would be 1.44 times 10 to the negative 8. And that would be your final answer, again in scientific notation, and then you're going to need to change that to standard form. And make sure you're watching that on your homework too, because it'll tell you how it wants the answer, scientific notation versus standard form, so just be careful with that. And last one right here, same thing. So 5.9 you're going to have to raise to the second power, and then times 10 to the, and you can multiply those exponents. So 5 times 2. So to the 10th power. So same thing as if this were x to the 5th raised to the second power. You would multiply those, and that would be x to the 10th. It's just that our x is a number this time. And 5.9 squared, you can put that into your calculator, and you get 34.81 times 10 to the 10th power. And again, if you notice this number right here, that's greater than 10. We don't want that. So we're going to move that decimal over one spot to the left to make it scientific notation. So this would be 3.481 times 10. And since we moved it over one spot to the left, that means when we would change it back to standard form, we would have to move the decimal one more spot. So instead of times 10 to the 10th now, I would have to move it 11 spaces, okay, since I kind of pushed it back. And so that would be your final answer right there. Okay, so again, apply that exponent outside to this number and also this one right here. And last thing we're going to look at is division. So with quotients, again, same rules. So you have numbers right here. They're just decimals instead of whole numbers, but you still divide. So I'm going to divide those first. So 4.9 divided by 2.5. And we get 1.96. And we have like bases right here. So in division, your exponents, you need to subtract them. So -3 minus -4 becomes +1. So this would be times 10 to the +1. So we were subtracting those exponents. -3 minus -4 is +1. And then again, standard form, make sure you change it in there. So this is times 10 to the first power, so you would still move it one spot to the right for your standard form. So your standard form would be 19.6. And then last one right here, divide 5.8 by 5, and you get 1.16. And then look at your exponents right here. So 4 minus -2, change to a plus, so 6. So times 10 to the 6th power right there. So use your properties or else it's going to be pretty confusing, okay? So like basis 10 to the 4th, again, is the same as x to the 4th over x to the -2. Subtract those and you get x to the 6th. Or you can even think about that negative exponent, meaning it would need to go up here. So you'd have x to the 4th times x squared, which is x to the 6th. And again, our x is just 10 here, okay? All right, so that's all you guys are doing today. This is going to be on your quiz that you have on Friday, so make sure you know this, and if any of it is confusing for you, feel free to come in Friday morning and we can go over it together in tutoring. Other than that, the other stuff that's going to be on your quiz is just the same properties we've been working with for a week now, or almost 2 weeks now. That multiplication of exponents, raising an exponent to a power, anything raised to the 0 power is always 1, and division and negative exponents, okay? All right, so make sure you get that homework done. If you don't finish it today, then just make sure you have it by class tomorrow, and I'll see you guys on Friday.